circulation. Here's how it normally works. Cars pull in, park for about 10 milliseconds, super fast, then leave. The space becomes available. New car parks. Cycle repeats. Fast circulation. This is efficient. A pool of just 5 connections can handle millions of requests per second because they're reused constantly. But here's where it breaks. What if one car parks for 10 seconds instead of 10 milliseconds? Maybe it's a slow database query, a stored procedure that locks, a network hiccup. Now you have 4 spaces left. If 20 more cars show up, meaning 20 concurrent requests arrive, 16 of them are waiting in a queue outside the garage. And here's the critical insight. Exhaustion isn't about having enough connections, it's about circulation speed. A small pool with fast turnover beats a massive pool with slow returns every single time. So, what happens when circulation breaks? One slow downstream dependency arrives. Maybe your database got sluggish, or an API you call got slow, doesn't matter. Suddenly, instead of 10 milliseconds, requests take 2 seconds to complete. They're holding connections much longer. T equals 0 seconds, you have 5 connections available. Everything is green. T equals 5 seconds, that slow dependency is still running. 3 requests are holding connections. Pool is down to 2 available. Queue is growing. T equals 10 seconds. 5 requests from your backlog finally complete and return their connections. But 15 new requests arrived in that same 10 seconds. Your pool is now exhausted. 0 connections available. Every new request that arrives gets queued. It waits and waits. T equals 15 seconds. Here's where it gets bad. Those waiting requests start timing out. They time out, so they retry. Each retry demands another connection from a pool that's already empty. The queue doesn't just grow, it explodes exponentially. 50 waiting, 100 waiting, 500. Your system hasn't crashed due to capacity. It crashed because one slow thing held all your connections hostage. And by the time your alert fires, you're already in the cascade. You can't recover because every retry makes it worse. This is why the best engineers treat this as critical. So, how do you catch it before it destroys you? 3 metrics. Monitor these obsessively, and you'll catch exhaustion before the cascade. First, active connection count. This should spike when load hits, then recover quickly as requests complete. If it stays at your pool's maximum for more than 10 seconds, that's a red flag. If it stays there for 30 seconds, you're in the cascade. Second, connection acquisition time. Normally, this is under 1 millisecond. Your app asks for a connection, it gets one instantly. But if this number spikes to 10 milliseconds, your pool gets congested. 45 milliseconds, you're dying. Third, connection failures per second. Healthy systems have maybe 1 failure per hour. A spike means requests are timing out waiting for connections. When this number jumps to 125 errors per second, you're already cascading. Most teams monitor CPU and memory. Smart teams monitor these 3. Why? Because these metrics are your canary. They tell you what's really happening inside your connection pool before the entire system collapses. When acquisition time spikes, you have minutes to respond. When failures spike, you have seconds. This is your early warning system. Now here's how you defend against it. 5 layers, each simple, together bulletproof. Layer 1. Right pool size. Most teams guess. Wrong. Use this formula. Pool size equals scores multiplied by 2 plus effective spindle count. For a 4-core system, that's roughly 10 connections, not 5, not 50, 10. Layer 2. Aggressive timeouts. Set tight timeouts. If a query takes longer than expected, 10 times normal, fail immediately and release that connection. Holding on to a broken connection is worse than having no connection. Layer 3. Bounded queues. Don't let requests queue infinitely. Set a maximum queue depth. When it fills, reject new requests. Yes, reject them. Why? Because trying harder when you're already broken makes things worse. Fail fast, let the client retry later. Layer 4. Circuit breakers. When connection acquisition failures spike beyond a threshold, open the circuit. Stop accepting new requests entirely. After 60 seconds, try a test request. If it works, close the circuit. If it fails, reopen it. This prevents cascading retries from hammering a system that's already broken. Layer 5. Observability. Log every connection event, acquire, release, timeout, error. When exhaustion hits, you need forensic data. Why did that connection stay open? Which request leaked it? Observability answers these questions. These 5 layers are what production systems run. They are not complicated, they are just intentional. And you're going to build all 5. You'll get working Python code, a connection pool manager with real-time metrics, event listeners that track every connection lifecycle event. You'll build a worker simulator that runs 20 concurrent requests. 30% of them are intentionally slow. They hold connections for 2 seconds. You'll run this simulation and watch your pool exhaust in real time. You'll see the metrics spike, queue length explode, errors cascade. You won't theorize about this, you'll see it happen. Then you'll tighten the constraints, remove the overflow buffer, set aggressive timeouts, watch the system fail harder, learn exactly why each layer matters. You'll implement a circuit breaker, add monitoring, test it under stress. All of this runs locally. Docker spins up a Postgres database. The script generates all the code you need. 3 minutes and you have a fully functional demo. By the end, connection pool exhaustion isn't abstract, it's visceral. Here's your path to mastery. Minute 0 to 30, read the master guide, study the diagrams, understand the root cause deeply. You'll learn why LinkedIn crashed, why Stripe had payment cascades, why your system is probably vulnerable. Minutes 30 to 60, run the setup script, execute the simulation, watch your pool exhaust live, adjust parameters, see how pool size, timeouts and overflow buffers change behavior instantly. Data beats theory. Minute 60 to 90, follow the implementation playbook, 10 steps, each one verified. Build the pool manager, configure it, implement the circuit breaker, add monitoring, write tests. Every step builds confidence. Minutes 90 to 120, stress test everything. Spike to 100 workers, watch the system recover. Leak connections intentionally, watch the pool degrade. You're not just learning, you're operational now. By 2 hours, you're not educated, you're weaponized. You understand this failure mode so deeply that you can prevent it, detect it, and recover from it in your own systems. This is what separates senior engineers from everyone else, the ability